right, I apologize about this, guys. Also about the very loud volume, apparently. Let's see here. I'm just gonna make sure that everyone gets the stream. All right. I hope everyone is well. Um, just gonna take me a second here. Apparently, stream still not being shown as live, I guess. Um, Not yet, not yet. Well, it's coming, I guess. I wanted to share the link with everyone. Let's see here. Perfect. All right, I can see the stream here. Let me just share it with everyone. Gonna post it on Discord. I apologize about the little audio hiccups. Just gonna paste it on the meetup group, and then we'll get on with this stream. I was very excited about this stream, and yet I still do everything wrong and everything the wrong way. Perfect. So, all right. Now we're here. You're here. I'm there. Let's start this over. We were supposed to be doing the HackTheBox Cyber Apocalypse 2022 challenges today, but because of that, because of the after party still going on, still have another 13 hours and 48 minutes to go and test these CTF challenges here. And I mean, there's no one that's too good or too bad to be going through these challenges. Um, they start from the very basic up to very very complex. I would say, I mean, if you did not have the time to register to the CTF, which was basically last weekend up until last Wednesday, I suggest you take a look at the after party. There's a lot of people sharing write ups, which is cool. So, I mean, even if you think those things are hard, as long as you learn a thing or two, I think at the end of the day, you're getting out victorious. You're learning something. You're getting part of the cyber community, and I mean, even if you're all by yourself, reach out to other people. You might be able to get other teams. Um, so essentially, it started on last Friday, and there was a couple of workshops. Now, if you want to look up those workshops, I highly suggest look up on the main Act the Box channel. They have all these videos over there, and very interesting talks from HipSec. There's one from NomSec. Um, and very other people as well. I apologize if I don't remember the names, but very very interesting talks. Now, from I'm just gonna shut down this here because I hate to have it. Awesome. Um, now. I hope you guys have been having a last couple of days. Last month we did a normal challenge where we hack a box, and let's take a look at what that interface kind of looks like, right? Shall we? Um, all right. So if we take a look when we first get into this act the box, first to access those challenges, you go at act the box or pardon me, ctf.actthebox.com, and you register over there. You create a team if you don't have one. By all means, it's free. It's fun. Um, Even if you think you're not good enough, I will repeat it. Everyone's good enough. There's challenges that range from easy, like this warm up challenge. Everyone can do that. It's just basically you go in Discord, and there's a flag somewhere hidden in there. Um, and before we head into these challenges and give a try of some of them, I just wanted to share with you guys that I recently got this shirt here. So and along with the shirt came. I apologize for the loud bang there, but came this. Let me just shut down a couple of stuff on there so you can see. But my computer logo gets in the way, and if not, it's my icon. So MVP of 2022. Essentially, you can be one as well. All you have to do is host up some of these meetup here's. Yeah, whether it be with this group or it could be with the group in your own area, right? Back when I was before I started this group about a year and a half now, um, I was attending the Act the Box Ottawa group, so pretty happy to say that I came from this group. There's a lot of um, nostalgia back we had when we had these meetups. People well known in the community used to go to these meetups. So I hope that one day my group or our group here will be just as good. So perfect. So let's get started with one of these challenges here, shall we? So I already downloaded the files, so we can go ahead and spawn the Docker. So I'm gonna do a little bit of challenge. I don't want to be spending a whole lot of time on the medium and the hards. I know you guys probably be interested in that. I'll probably be releasing some more write-ups through the week. So be on the lookout for that. If not, then other people will be definitely. I mean, until this after party is done, a lot of people on the HackTheBox Discord will be sharing. So I got my things here, and I got my Kali Linux going on. So here I picked up the pawn getting started. Very fitting. Um, so essentially, we know that the flag is on the same directory as our program, and that it runs glib6, right? Um, Now we can do strings, but since there's a Docker container, I can tell you probably there's nothing that has to do anything with strings over there. Um, But we can definitely run that executable here getting started, and it's basically just a buffer overflow. So instead of doing it over there, let's connect to this here. So this is what we're being prompt with. And essentially it just tells us basically how the stack is laid out. So it's very simple. Smash the stack application where the end target is basically we want to change the address here. So usually what happens is that the what we want to change is the return address here, so we can basically jump in time in our program. Now, but since this is just showing up, if we rewrote the return program with a false or an address that's outside of the program, we would be granted with segmentation fault. So because of that, basically, we this challenge doesn't ask us to do that. It basically asks us to change the value just before it, right? It wants to be safe. It wants to be able to return within the program, within the parameters of the program. So it has a certain portion of the memory that we're allowed to modify. Now, here's what it says when we read it. It says, so this is exactly how the stack is that's how they call it. It's a stack because the way that assembly is stacking memory is basically it's first in, first out. So it's like think of it like you know when you were kids, those little rings with those little posts, and you used to swing them, and you had to swing them until the bigger rings was lower, and they would get up all scrambled. You'd have the three posts, right? So it's essentially the same thing, right? You can't take out the one from the bottom without taking all the ones that's above them. So, and instead of having three posts in this case, we only have the one. So let's take a look at what it's doing. It says, so it's initially this is what the memory looks like, right? We got a bunch of 69s here. They're dummy values for alignment, and we got the target value we want to change. Now, and it says if we insert 4A's in the stack, here's what the memory looks like. And this is important, right? So it has a bunch of 41s, and the hexadecimal code for A is 41. So because of that, that's why we see all those 41s. Now it says after that, if we answer 4A's and 4B's, well, we get this. Okay, so let's try to do this, right? So we're gonna get 4A's, 4B's, but we know it's only filling up the one row. So let's do C, D, 4D's, 4E's, 4F. Let's see if that's enough. Oh, we failed. Okay, let's see what we did wrong here. So what happened here that we did not succeed in this smash the stack challenge? And essentially is that we only modified the first three rows, right? If you look at it, there's A, B, C, D, E, F, but we want to be changing that red row over here, so we're not achieving this with only those. So since we're only modifying three rows and we want to be modifying the three extra rows, I'm just going to copy that value and paste it in double. So paste. We're going to enter, and essentially we got the flag. So we got the values we wanted to change. Now normally you wouldn't change this just to random values of E's and F. You'd be looking for a certain pointer in address, so a couple of zeros. So you'd be looking at something to spoof something similar to that, right? So as long as you get back to that address, and we could probably test that, right? So if we return this, and now what we want to do is we'd have to double check what all these values were in hexadecimal and translate them. Some of them might not be, so we might not be able to do that because some of um, these values might not be hexadecimals. So, but let's test something else. So, what happened if we, remember if I told you that if we go past that return address, we'll basically be going out of bound with this code. So instead of pasting 2, we're gonna go 3 lines down. So we're gonna go all the way to this line here in memory. Let's see what that does. Well, in this case, it still worked. So we did not crash the whole stack. Sometimes, I mean, normally we would see. See, it still changed all those addresses. So the buffer we see here, there's probably a whole lot of space before we ran out and we crashed this. But let's see how much it can take. Because I was expecting it to give us some kind of segmentation fault after a while. Maybe we don't see the segmentation fault because the way that the program exits. So if we do it over here, yeah, you can see there's a segmentation fault because we basically went way up past the buffer, and that return address is basically going out of bound. Like this 444 address doesn't exist within. Like these are all the addresses within our program, the first colon, right? So this 464646 doesn't exist within the scope or the boundaries of our program, and because of that, it's segmentation fault. You're basically trying to access outside of the memory. So that's it for this challenge. So now we got the flag. I mean, we got it a couple of times. Um, It's gonna be a whole lot of judge hacking, I think, on this episode on this stream. I apologize for that. I hope you like it. I like this format. Um, I just wanted to take advantage because um, I wanted to take advantage of the HackTheBox CTF, but I kind of forgot to tell it last month. Um, I have to be a little bit more proactive with that. And so that's that for the pawn. Let's jump to the web. Um, the web, there's this one here that originally I did not, I was not successful to complete it, but I think it's very important that I show you guys later. So, I mean, this one, if I remember, it's pretty easy. So let's go back to our Kali box here. And since this is a web page, okay, we don't need the burp. I'm just going to close it, refresh. All right. So here we're prompted with a pretty simple challenge. Essentially, it asks us, and I mean, here the first thing I would say is like, let's check what it's doing in the code, and we can see that the code is 8291. Just by looking at a quick look at the source code. So if we try that 8291, sure enough, we got the flag. So this one was pretty easy. Let's jump to another one, gunhead. I think the one is about an SQL injection. Let's double check on that. No, this one's an actually simple command injection. So there's a slash help. It's kind of IRC style, so we can do slash help slash ping. So if we can do ping 127.0.0.1, then we know that basically this thing is able to ping. Now, what about if we do ping 0.0.1, but at the end, let's add a semicolon, because that's what bash command takes, and let's do UMI, right? So it tells us that the ping's working and we're www. Now we can do in ls. We see there's a couple of files over here, so let's just run the command again. And I think it's in the root folder. So if we do ls, it's over here, and then now we can just do a cat slash flag.txt, and we got the flag that says we always have to sanitize user input. All right, so let's do another one here. We're gonna do 2 more of those webs. I want to do more the other stuff as well. So the DrewBots is pretty cool. Those I haven't really looked at the source code, because I don't think you kind of need to look at them. When you get on the page, it's pretty simple what you have to do. This one I kind of did. I did look at the source code, and let's take a look at the source code, see what's wrong with this code. So if we do go to web and then DrewBots, basically this is what we get. There's a flag. We got the entry point. So if we look at the entry point, basically tells us what happens, right? So we know what the password, the SQL is, but I don't think that's the point, because that's not exposed. Sorry. And if we go into the challenge now, there's a run within the application folder. Basically we got a main file, but the thing we want to be looking at is the database.py. Basically, where I was able to see that this probably is vulnerable to SQL injection is that it just basically puts the username and password straight up. I apologize for I was whatever. Sometimes different way I'm facing, it seems like the mic is picking up a little bit. I'm still getting used to that mic, so I apologize for that. So essentially, what it's doing here, it's doing some injections, and it's injecting that username and password straight up into the query, and if we go back to this here, we can see that there's basically only the one user, this is the admin. Right here. So it's doing like a admin, and it's doing an import with the password, the random password. Essentially what I did here is we want to see what this query looks like. So it's doing a quote, a double quote. So we're going to do a double quote, and then we want to do a comment, a space, and just a random character. The reason is sometimes if there's no space behind the quotes, it can screw it up. And if there's only a space at the end, sometimes they get taken out. So that's why you do a space and then something else. The password doesn't really matter. It just punched in anything in there. Just as long as there's something, and we get the flag. Perfect. Let's get to this. Passman here. This one was pretty interesting. Now, it does require a little bit more work, but it's a little bit more fun as well. So that's not what I want. So we get to this page here. So I'm just gonna open the burp suite. It can be burp, it can be zap, whatever floats your boat, right? I'm just gonna be using burp for now. Make sure that the proxy's on. It's not intercepting, so we can go to the history. Perfect. So what we're gonna do here is we're gonna register an account. So it can be psycho.ca and password just ABC123, right? We're gonna sign up, and we want to be looking because we can look at the code as well. Web passman. So if we look at the entry point always tells you a little bit how this application is being laid out, right? If there's a database, the Docker will be creating the database. It will be doing something. Here we can see that there's a bunch of passwords, a bunch of stuff in the password manager. But this admin password here is what we're really after, right? So at first I thought it was an SQL injection, something typical like that. But then when I start looking at the application, I saw that this was built using GraphQL. So I thought that perhaps the problem would be with the JWT token, but here it's setting up a pretty long key, which you're not able to brute force. HS256, I mean, you probably want to be using public and private key type of deal, something like RSA, but I mean, as long as you have a key that you're able to keep secret, you're good to go, in my opinion. Now, I would still recommend to use RSA anyway, just because you can get away with a lot of these. It doesn't mean that it's a good thing to do, right? Now, since that's not the problem, I figured I'd look at this GraphQL thing, and there's a couple of functions here. Mutation, if you want. Mutations is basically functions. So if we look how this query or how this registration went when we registered to the system, there's this GraphQL query that went through, and it basically mutates the data, right? So it tells us like, okay, we're expecting a string and we're passing it to this command over here, and so, but wait a second. Let's go back to this code. I mean, sure enough, like it sure signed the token when you log in. There's an update password, and I didn't, and probably this is my inexperience with GraphQL, but I didn't see that at first. So essentially, what happens over here is that um, this this query, like, sure enough, it needs you to be logged in, right? Because it tells you authentication required if you don't, but doesn't really check who you update your password to, right? So we have this update password function here. And we can, so let's do a little bit of modification to our query. So we don't need the email thing, right? So let's take that out. Well, first of all, we're going to have to send it to the repeater. So send that to the repeater. Then over here, we're just going to delete all the email because we don't deal with any of the email. We just need username and password, essentially, right? So we keep this parentheses, and we're going to get rid of the emails and the variables as well, right? Now, instead of sending registered user, we want to send update password. We've seen that. And let's try to update the password of the admin just for the heck of it, because why not, right? ABC123 seems like a secure password enough. No one will guess it. Like, it's not like it's in a password file called RockU or any other password files, right? It's only one of the top 10 password used on the planet, so it's pretty secure, right? All right, so if we send a query like that, we get this authentication required. Oh, but there's one thing we forgot, right? We kind of forgot to log in. So let's log into our own account. And what's going on, we need that JWT token. So if we go back to burp, now we go to the proxy and HTTP history. We go to the login statement. So we get this login. It gives us a session cookie. So we just basically need to copy that session token here. Go back to the repeater, paste that below here, and just resend the query. And it says, sure enough, password updated. Well, let's see if that worked, right? So if we go to admin, admin, our very secure password of ABC123, and it says user logged in successfully. And if we do show password, well, sure enough, IDOR is simple and impactful. Yeah, very simple IDOR, but yet pretty effective, right? Awesome. Let's move forward here. What time is it? 41. We still have quite a bit of time. Awesome. That's great. Like I said, the more I've learned a thing or two on these challenges. The more you learn, the better it is for you, right? Here's where I learned one. Very easy, yeah, sure enough. But I didn't know. I'm not very agile, let's say, with Python. I'm still learning it, so I mean, I'm pretty decent. I think I'm a pretty decent programmer anyway, but I still haven't figured the ways of the Python, right? So let's take a look at this challenge here. So blockchain, navigating the unknown. So this one I banged my head quite a bit because, well, we're given this setup and this unknown contract. So there's basically solidity contracts that execute functions on the blockchain. Now, it's all great. There's not a whole lot. Here's how it's all set up. And here is what it does. So as long as you call that function with a value of 10, it says the updated value to true. Okay. Now, we're given two IPs, and I didn't understand quite what they were doing at first. I mean, this one seems pretty obvious. It creates a connection information. So I thought, well, it's probably your way into the blockchain or like, but also there's another IP address, right? If you look at this, there's two Dockers. And this is what I didn't understand. And so essentially, you can interact with, I mean, the people who are better at Python and Web3 are probably laughing their asses off at me right now. But I was still learning. I'm still learning, right? Everyone's still learning. So I found this script basically that allows you to create a connection. So we just need to tell it the this, and we need to tell it the target address. And the target address, we got that earlier, right? So let's get that target address here. So that's the target address, the contract. And we're just gonna paste that into this code. And let's go through what this code does. So at first, at the top here is basically it imports like all these Web3 and all these Solidity version, right? And here it basically makes sure that it's using a Solidity compiler, but it's mashing the same version of the source code we had, the unknown.solidity, right? Now it opens the file, it reads it, it puts it into a variable, and then it wants the ABI. Once we we put in the contract, and then we open the connection using the Web3, and then we give it the address and also the ABI, that ABI, right? It's needed for the contract. So, and once that all is done, we basically call the function, the update function, give it a value of 10, and we send it to do the transaction. So it looks cute and all, but if we run it, it looks like this. There's not a whole lot of output. And essentially what it does is it runs that contract on that blockchain. I might have given it the wrong address. Let's see here. Let's see. Yeah, I think I did. So there's two IP addresses, and I probably give it the wrong one. This is the one it should be having. All right. I'm pretty certain I gave it the other one. All right, see, it ran. Now, if we go back to that first address we connected, oh, it's not that one. This one. and we punched in number 3, basically it says, well, the software has been updated, so we're getting the flag. So here the setup basically is provided to you because they want you to know what's going on. But that's already being ran in the blockchain when you call that get information, get connection, the number 1 option, right? Or when you restart the instance. That's basically the setup file. That's the setup that's being run, right? So you just need to connect to that right address, and once you connect to that contract address, then you're able to basically execute that software. That's something I need to get better with, to be honest, because I definitely like the blockchain. I like everything about it, and I want to get better at it. All right, let's get to miscellaneous. Jenkins. Jenkins was pretty interesting one, basically. So this one you're provided with the source code. You're also provided with the Jenkins application, and the rules are pretty simple. You have to win this game of rock paper scissors 100 times to win the prize. Now the prize being is these flag that we need, right? The HackTheBox flag for the challenge. So once we hit the 1, oh, I did hit the F1. That's not what I was looking for. And let's pick rock. We lost. Okay. Rock. Oh, we won. All right. Now paper. Oh, we won. Scissors. We lost. Okay. What about if we put banana? Does it work? No, I lost. It's not in the... Alright, what about rock and paper? Oh, that worked. Rock, paper. That worked. Rock, paper. That worked. Rock, paper. Oh, I lost. I needed to do scissors, right? So, what if I put in rock, paper, scissors? Basically win every time. Okay, so it's basically just, it's not checking the whole word, it's just checking, make sure that the values present. So I'm not gonna be pasting 100 times, so I made this script here. I just need to give it the IP address. And once I run that script, did I give it the right address or did not? I probably did not because I still have those open. So let's go to miscellaneous, the Jenkins, and let's start the Docker container. Take the IP address. Go back to our Kali box. Let's put this information in here. It's gonna do that 100 times, basically winning every single time because it has all the possible options, and then it just gives us. We got the logic bug, right? Perfect. All right, there's a. Let's do Couple more. It looks easy because I'm doing them after I did them a couple of times, right? But I assure you, the moment that I did them, it took me a little bit more time. This one's pretty easy. This one, I got to practice my Python skills quite a bit, and I did not do anything else but create the Python script for this one. So let me go over what the Python script is. Um, so essentially, um, that's the script that I wrote before I did the Jankim, and I just reused the Jankim for that particular version or application. But essentially, this one here is pretty a little bit more complex because it needs to let's play the game first before we run any script and we hack this. Let's play the game. So we have it out. So we can. It's telling you. It's telling us that the results are rounded 2 digit after the point, and you cannot divide by zero. You cannot have an invalid syntax, and memory. There's a memory error if it's bigger or smaller than plus or minus leet. Now, if you do start, it's basically just giving you all these equations, right? So essentially, I have created this script that just runs all these equations through an eval. It's probably not a whole lot secure because eval is not very secure. And hijacking this would probably while I'm on stream would probably be hilarious. However, and it's not perfect, right? So it needs to run 500 of these equations and be right all the time for it to succeed. So, well, I know for a fact there's a couple of instances of bad, invalid syntax that it doesn't know about. So if we run into one of these, I would have to add it to the code, which would be a good learning experience, to be fair. But I've ran this code a couple of times, and I've didn't run across them yet. The first few times I ran, I ran quite a few problems. It tries to do an equation with a plus and a minus in it, and it's all funky because it doesn't like that. All right, so eventually we do all 500s of them, and you can check if you want. They're all correct, or should be all correct. The ones that doesn't have answers because we answered the error code that the game wanted us to. And essentially, that's what this little challenge was all about. Now, let me check. All right. We still probably have time for one or two. These hardware ones are, I find them pretty daunting, pretty hard. But let's see this one. Let's see if we needed to download the tool. So we got the logic analyzer. We need that one. and it runs that SLA. So we're always, I mean, often, more often than not, I do see those coming in CTF, where we're provided with a .sal. It's just a hardware capture file. Then time transmission. Essentially, you just get all kind of stuff like that, right? Um, but once you start like playing with a little bit with the timing, that's why he says timing. You can see that kinds of seems like it's writing something, right? But because it's actually doing just that, that's our flag HTB, and then the begin the hardware quest. So this one was a little bit fun to get. I showed you this one because we always kind of get those weird hardware ones where you just have to play with the timing. And a needle in the haystack is pretty simple as well. Um, Essentially, it's just a binary file that you need to find the flag into. Um, so we got this A stack. Right? But if we do strings on the A stack, we can get to the flag. That's also an easy one, pretty easy one. But sometimes when you do debugging or reverse engineering, it can be helpful. Right. Let's do a forensic. So if we go to the so forensic rotten. So sudo, we need Wireshark and forensic rotten. My big password that's not ABC123. Um, and then we get this Wireshark capture, right? What could it be? What could it be? So it's a fuzzer. I think that's one of the ones that I didn't complete. If we look at all the objects, you can see where all these galactic map was were called. Mm. It was basically just doing a bunch of I don't think I know the solution for that one. Let me another one. Um, since we're almost done here, so let's do this one. I want to do so I usually go to the file, go to export object, and list all the HTTP. If I see there's a lot of HTTP traffic, right? Now, we get this material design icon. We get this token. Essentially, if we do follow TCP stream, we can see that they do a post for the token. So, Mr. Cosmic Operator with the password of the HackTheBox flag. All the token type and all the information is doing more stuff afterwards. But essentially, we just needed the flag. So that was basically in a nutshell, or an overview, if you want, of some of the challenge that you can expect to see in a CTF, like Hack the Box, Cyber Apocalypse. Now, don't worry if, like I said, if I went too fast, or you think, oh man, this guy knows a whole lot about this, he's going through this like it's nothing. Um, Rest easy. I did bang my head all weekend to solve these handfuls of challenges. Um, and some of the challenges that I present to you this tonight, basically, I did not even didn't even looked at them, or didn't even solve them in the CTF. What I meant. But don't be discouraged. To me, I've went to different CTF quite a bit through the years. My goal is always to learn at least one thing. If I can learn one thing or at least a thing a day or something like that, if I can learn something big through a week or a couple of things here and there, like that's the purpose. That's what you need from me. Um, so that being said, I think we're gonna call it a night. I've been talking a lot, not a whole lot of. We didn't take any breaks this time. Um, I want to try to do them more often if I can. All in one go. Um, I think it's a little bit more captivating. It's a little bit less boring, but sometimes a good 5 minute break doesn't hurt either. So that was it for the HackTheBox CTF. I hope you liked it. My name was Tony Psycho. I just realized I didn't do any introduction. My name is Tony. For the ones who don't know me, I go online by the name of Psycho. And this was HackTheBox Meetup, the Moncton group. Peace out. See you next month.